So the question is that the initial rate of a reaction for propanone and iodine in acid solution is measured in a series of experiment at a constant temperature. The rate equation, so they've given you the rate equation, and the order is also actually mentioned. By default, if nothing is written, that means it's order one. Okay, that's order one. So state the order of the reaction. So there are three things. There's this ketone, there's this iodine, and they've also included H plus one, the catalyst. That is also affecting the rate of the reaction. And remember, a catalyst always affects the rate of reaction. If you add more catalyst, the reaction would speed up. Now, according to the rate equation, the rate is dependent on these two. So it's order one. So it's order one with respect to the ketone, and it's order one with respect to H plus one. But since there is no iodine mentioned in the rate equation, that means it's order zero. Rate does not depend on the concentration of iodine. And the next part is, and state the overall order of the reaction. So what's the overall order of the reaction? The overall order is you sum up everything. Okay, you sum up all the orders. So it's 1 plus 1, which is 2.
Two.
Okay, is this clear? Sarah, clear? It's Akib.
Yes, sir.
Now,
Yeah.
so now the next part of the question is the rate of this reaction is 5.4 times 10 power minus 3 mole per dm cube per second when. So they've given us the rate of the reaction. They've given us the concentration of the reactants, the three of them, and they're asking us to calculate the rate constant and state the units of K. So what we're going to do is we already have this rate equation. So I'm just going to put these values over there. Take out your calculators and tell me what the answer is. So I'm just going to substitute these values in the equation above. So it's the rate is 5.4 times 10 power minus 3 mole per dm cube per second is equal to K times the ketone concentration, which is given as 1.5 times 10 power minus 2 multiplied by the H plus 1 concentration. So the H plus 1 concentration is 7.75, and that's into 10 raised to power minus 1. Try and find what the value of K is. I mean, this entire thing is going to be, so this entire thing is going to be divided by, 1 second.
0.56.
ठीक है. Are you sure? Could you all reconfirm?
Yes, it's correct.
0.5?
0.46.
ठीक है, so it's coming out to be 0.4.
56. No, it's 56.
Mehfooz, did you try this? Sorry, can you check again? Just check.
Is it 4.6 or 5.6?
I mean, one of the, you are saying it's 4.6.
It's 5.6.
So just try and reconfirm. I mean, it's going to be 5.4 divided by 1.5 and 7.75, and the bottom is, I think, 10 power minus 3. So the 10 power minus 3 part gets cancelled out. So it's 5.4 divided by, I think it's 5.6. Okay, I'm just guessing it's coming out to be 5.6. So okay, let's take it at 5.6. How do you find units? Remember, I told you that. Can anyone tell me what the units are? How would you find units? Mole per dm cube. Take mole per dm cube as x. So rate is mole per dm cube per second. So it's x s minus 1 is equal to K times mole per dm cube into mole per dm cube, right? So x, so it's going to be x squared at the bottom, and K would be equal to x minus 1 and s minus 1. Now x is mole per dm cube, so it's going to be mole minus 1. dm would become 3 and s would become minus 1. Okay, so those are going to be your units. Is this clear? Mehfooz, Sarah, Akib, is this clear?
Yes, sir.
Yes.
Yes, sir.
As a next part, complete the table by taking one by placing one tick in each row to describe the effect of decreasing temperature on the rate constant and the rate of the reaction. So I told you, TK, I told you about this, that rate is dependent on the concentration of the reactants, right? It's dependent on the concentration of reactants, and A is the order. Now, now it does not represent temperature. Temperature has no role in this. Okay, there's no. So I told you that if you are not increasing the reactant concentration, you're not changing the order. The order, I mean, obviously you can't change the order. TK, every reaction has a very fixed order. And by increasing temperature, the rate increases. So that means temperature has an effect on the value of K. TK, K is a constant, but this constant, I told you it increases with temperature. TK, because if you're not increasing the concentration and still the rate increases, that means temperature is affecting the value of K. So it's going to be, the rate constant would be higher and the rate of reaction would be higher as well because temperature increases the speed of the reaction. TK, is this clear? Sarah, Akib, is this clear?
Yes, sir.
Yeah.
As the next one, from the results, a graph is produced which shows how the concentration of I2 changes during the reaction. I mean, I2 is one of your reactants. So it's going to decrease. It's going to get used up. So how could you determine the initial rate of this reaction? What you're going to do is you're going to plot a gradient right at the beginning. Okay, that's, let's say this is the gradient. So describe how this graph could be used to determine the initial rate of the reaction. So that's how you're going to do that. I mean, I'm going to check the marking scheme for this as well, measure the gradient at t is equal to 0. Okay, so I'm not sure why they've given you 3 lines. Let me open the paper. This is S19QP42. Just one second, let me quickly, 9701. Okay, just confirming why there are 3 lines. And we can also check, just wait a second, which one is the... No, Akib, it was 0.46. I mean, over here it's given as 0.46. TK, not 5.6. यहाँ पे क्या, why are we getting this wrong? 1 second. Did we misread the question? Sorry, you're decreasing temperature. So the rate would be lower and the rate constant would be lower, okay? Is this clear? Akib, Sara, is this clear? Mehfooz, clear?
Yes, sir.
Yes, sir.
Yes, sir.
This one, straight line graph starting at 0, 0 and showing... this one. Draw a tangent at time t is equal to 0. Measure the gradient slope of the tangent. So that's pretty much it. I mean, both of them pretty much mean the same thing. So that's measure the gradient at t is equal to 0. I think that pretty much sums up both points. Next one is on the axis below, sketch a graph to show how the initial rate changes with different initial concentrations of CH3, CO, CH3. Remember that in this reaction, the rate was order 1 with respect to CH3, CO. Okay, right at the beginning, they've already given you the rate values. Okay, the one that was given over here. It's already described as order 1 with respect to. So that means it's directly proportional. What does that mean, directly proportional? How would the graph look like for a directly proportional uh, relationship? It's going to be that if you increase the
Straight line.
it's going to be a straight line. If you increase the concentration, the rate would also increase. That's it. The next one is the rate of a reaction between metal ions was studied. The following three-step mechanism has been suggested for this reaction. Which reaction? As it's a completely different question. I mean, it's related to the first one, but the question is about a different reaction. The following three-step mechanism has been suggested for this reaction. Step one is the rate determining step. So step one is, in this case, your slow step, which means your rate is dependent on the concentration of. Remember, rate is only dependent on the reactants that are involved in the slow step. So it's going to be dependent on the concentration of Ce4 plus and Mn2 plus. Okay, that's it. Explain the meaning of the term rate determining step. So it is the slow step in the mechanism. That's it. So use this mechanism to determine the overall equation for this reaction. How would you determine the overall equation for a reaction if different steps are given? The simple answer is add all of them. Okay, if you add all the steps, you're going to get your mechanism, not the mechanism, the overall reaction. So these are your reactants. Add all of them. These are your products. Add all of them. So if I start doing that, it's going to be Ce plus 4, starting with the top Mn2 plus, I think. Then over here it's Ce4 plus again. So that's 2 Ce4 plus now. And then there's Mn3 plus, there's Mn4 plus, and there's Tl plus 1. So these are all your reactants. And what are being produced in all the steps? It's Ce plus 3, it's Mn plus 3, Ce plus
2C.
that's a 2Ce plus 3, there's an Mn plus 4, then there's Tl3 plus, and then there's finally Mn2 plus. Now you're going to simplify this. What you're going to do is you're going to cancel out anything that is the same on both sides, like Mn2 plus. There's Mn2 plus over here, and there is Mn2 plus over here. So that means it's not doing anything in the reaction. It's not involved. It's not involved in the overall reaction. So there's Mn3 plus on both sides. Remove that. There's Mn4 plus as well on both sides. So the final reaction that you have is 2Ce plus 4. The other thing is Tl plus 1. And the product is 2Ce plus 3, and the other thing is Tl3 plus. So that's your overall reaction. So suggest the role of Mn2 plus ions in this mechanism. Now Mn2 plus, remember, were added at the very beginning of the reaction. You can see Mn2 plus added in the beginning of the reaction. And right at the end, Mn2 plus is being produced again. So what is that thing that remains completely?
Catalyst.
So it's a catalyst, okay? And it's what type of catalyst? Because you've given 3 lines.
Ce3 plus.
नहीं लेकिन नहीं अब हो रहा है C3 plus catalyst नहीं है क्योंकि C3 plus शुरू में you didn't add it in the reaction, वो तो it was produced in the middle and
TL.
नहीं TL is also not a catalyst. Catalyst क्या है कि you add it in the start, so at the end it remains completely unchanged. So it's only Mn2 plus. ठीक है?
अच्छा.
So Mn2 plus जो है, that's a homogeneous catalyst. This is the word that was missing. क्योंकि it has the same state, aqueous ions है, homogeneous catalyst. ठीक है, I think it's a 2-mark question, so only catalyst would not do. And explain your answer. It's added at the beginning. And remains completely unchanged. At the end, just to confirm, because we have the marking scheme open, कि हमने सही लिखा है गलत लिखा है. अच्छा, homogeneous, no mark for that, ठीक है. And it's the same, कि reformed or at the end of the reaction, you added at the start and it's again present at the end of the reaction, ठीक है. So remains unchanged. Like it's better to write homogeneous. As the next one.
ने mn 2+ लिखा ही नहीं हुआ
किस में?
मार्क्स स्कीम में.
नहीं, mn2 प्लस उसने खुद ही दे दिया, सजेस्ट द रोल ऑफ mn2 प्लस.
अच्छा.
ठीक है, तो वो तो उसने खुद ही दे दिया था. अच्छा, so the next, अच्छा लेकिन just वो अबू रहरा, just remember कि catalyst, अच्छा remember इसके अंदर look at, I mean there are other things that remain unchanged as well. mn4 plus है, वो बाद में there's mn4 plus again, ठीक है. But remember mn4 plus is not a catalyst, क्योंकि mn4 plus is an intermediate. Intermediate और catalyst में remember the difference. The difference is कि catalyst is added right at the beginning, step 1 के अंदर it's added, or in the last step it would be present again. ठीक है, that's what a catalyst does. mn4 plus wasn't even present in the beginning. ठीक है, इसका मतलब है you're not adding mn4 plus. mn4 plus was formed somewhere in the middle and got consumed somewhere in the middle in step 3. So you don't have anything to do with mn4 plus. ठीक है, you're not adding it. The reaction itself is producing mn4 plus and the reaction itself is consuming mn4 plus at a later stage. तो कैटलिस्ट आप डालते हो, ठीक है, वो आप स्टार्ट में ऐड करोगे. तो रिमेंबर दैट. मतलब अनचेंज तो बहुत सारे mn3 plus also remained unchanged, but mn3 plus is an intermediate. यानी it was formed somewhere in the middle, mn3 plus, and then got converted from mn3 plus to mn4 plus. So that's also not a catalyst, that's an intermediate. ये वाली बात clear है सारा? अबू रहरा, Mahfouz, is this clear?
Yes, sir.
Yes, sir.
अच्छा,
Yes,
next one. You have chlorate 1 ions undergo the following reaction under aqueous conditions. So obviously you have just these two things. Rate would be dependent on these two things, or as a rate would be dependent on these two things. Use the data. दोनों के respect से order. अच्छा, first thing, which two experiments should I compare? Well, CLO minus 1, let's say CLO minus 1 का order निकालना है. So which experiment should I compare?
2 and 3.
No, actually, you can't really find CLO minus 1 order because if you want to find the order of CLO minus 1, then CLO minus 1 should be changed. But there should be variation in CLO minus 1, and the rate would change, and you would find the relationship. The other reactant should remain constant. The problem is that NH3 does not remain constant in any of the steps. Okay, if you compare 1 and 3, the CLO minus 1 is changing. It changes from 0.2 to 0.4. Lekin at the same time, NH3 also changes. You don't want that to happen. Okay, because you don't know कि rate के अंदर जो change आ रही है, there's a change happening in rate. Now you're not sure कि is this change happening because you're changing NH3, or is this change happening because you're changing CLO minus 1? ठीक है, आखिर is this clear?
Yes, sir.
Achha, so initially, I don't think you can find CLO minus 1 concentration, but if you compare 2 and 3, so CLO minus 1 remains unchanged. So इसका मतलब it's not going to affect the rate of the reaction. ये किस factor से change हो रहा है? What's the factor that? How many times is it changing? NH3 concentration. 0.2 to 0.4.
2.
Okay, so it's 2x, 2 times. How many times is the rate changing? And if you get confused, divide this number by this number. What's the value that you're going to
By
get?
4 times.
Okay, so it's 4 times. So what is the order with respect to NH3?
2.
Second order.
Okay, that says order 2. So question के अंदर you have to write the answer very carefully that you're comparing experiments 2 with experiments 3. And in those experiments, you notice that NH3 concentration is doubled and rate quadruples. Hence, order with respect to NH3's concentration is 2. He gets order 2. I said, now the problem is, how do you find? I said, now you already know that the order with respect to NH3 is 2. Okay, so that would kind of make it easier to find the order. I said, remember, it's a 2-mark question. You just got 1 mark for this. I said there are mathematical ways of actually solving this, but you don't have to. I mean, you're not expected to go into a lot of detail, and there's not a lot of marks for this. So when you're reading the table, like the way that we have done over here, you have to be very direct. Okay? You just have to look at the table and estimate what the order is. You don't have to go into details because the other part is finding the order of CLO minus 1. You're just going to get 1 mark for that. Okay? So that's the amount of time that you're going to spend on this. Okay? Approximately, you should just be spending 1 minute. If it's a 100-mark paper, each mark is for probably just 1 minute because you have 2 hours for it. I said, so how do you find CLO minus 1 order? Because if you compare any experiments, okay, like you're not going to compare 2 and 3 because in 2 and 3 you're not even changing CLO minus 1. So how can the rate be affected by CLO minus 1? So that's out of the question. And vice versa, if you compare any like 1 with 2, the problem would be that NH3 is also changing. So that's an issue now. So one way to do this is to just think mentally, because we already know that the order with respect to NH3 is 2. So the first method is, how many times is this increasing? It's being doubled, right? I'm comparing
Yes.
I'm comparing 1 and 2 because I don't have a reaction in which the NH3 is constant and this is changing. So I have to deal with this. I said, but the problem is that NH3 is also changing. NH3 is changing by 2 times as well. Now the good thing is I know the order with respect to NH3. So if I change NH3, if I double the concentration of NH3, the rate should be 4 times. So what's 0.256 times 4? 1 second, calc.
It's 8 times, I guess. 8 times.
No, no, I'm just saying 0.256 star 4. It's coming out to be 1. I said it's coming out to be 1.024. I said 1 second. Let me explain this. So the issue is focus. 1 second. I said so the issue is focus on this part first. Okay, remember we know the order with respect to NH3. So I'm not trying to find the order with respect to NH3. I already know this. I did this in the last step. I mean, we already found this. So NH3 concentration is being doubled and it's order 2. So that means the rate should be quadrupled, right? So it should be 1.024, right? Did you get this point? I mean, instead of 2.05, it should have been 1. I mean, if you just ignore CLO minus 1 for a second, the relationship between NH3 and initial rate is order 2. So that means if you double the concentration of NH3, the rate should be 4 times, right? So it should come out to be 4 times. Is this clear? Abu Huraira, yahan tak clear hai? Akib, Sara, Mahfouz?
Yes, sir.
Could you repeat it
Yes, sir.
last
ठीक
one,
Yes, sir.
please?
Acha, nahi, Akib, what I'm saying is, I'm trying to compare experiments 1 and 2, but I'm totally ignoring CLO minus 1 for a second. ठीक है? ये जो first वाला, I mean, just ignore this for a second.
Right.
What I'm saying is, you've already found the order with respect to NH3, right? But when you did all of this, you found the order with respect to NH3, ठीक है?
Yeah.
इसका क्या मतलब है कि if you compare experiments 1 and 2, ignore the first column for a second, NH3 concentration is being doubled. So the rate,
Yeah.
how much? 4 times.
Yeah. Exactly.
ठीक है? So,
Mm-hmm.
so it should be 4 times. Now I'm going to look at the first column. Why isn't it 4 times? I mean, it's doubling again. The actual value that you're getting is, ठीक है? The actual value that you're getting is 2.05. So it's actually double of that, right?
Yeah. 8 times it is.
So total 8 times. So who's doubling it again? It's because of CLO minus 1. You get my point?
Right. Yeah. Got it.
So that means that if I double CLO minus 1, the rate over here doubles. It should have been 1.024 because of NH3. Okay, so I've removed NH3 I've basically figured out the effect of NH3 on the rate. It should have come out to be 1.024, but it's actually coming out to be 2.05. That means this value is doubling again. So it's probably doubling because of CLO minus 1, because you're doubling CLO minus 1 as well. Baki ko clear hai? Mahfouz, is this clear? Abu Huraira, Sara?
Yeah.
yes, sir.
Clear.
Yes, sir.
तो इसका क्या मतलब है? The order with respect to CLO minus 1 would be 1, right?
Yes.
ठीक है? अच्छा, the other way, the mathematical way, because it's a 1-mark question. The whole problem is it's a 1-mark question. So you just have to, if you found the order with respect to a few of the reactants and you can't find experiments where this reactant is constant and you're just changing this, so what you're going to do is, because you know the order already, so try and figure out what the effect of NH3 would be on the rate. And then try and figure out what is this doing then. Okay? The other way is, and that's the mathematical way, the other way to do this is take experiments 1 and 2. Okay, so let's do the other method. That's the mathematical way. Let's say you take experiments, let's say you take experiments 1 and 2. And what you're going to do is, you have the rate equation with you. The rate equation is K times CLO minus 1 concentration. You don't know what the order is. So that's X. And NO's concentration, and you know the order for NO, that's 2. Okay, you take rate. And you substitute values for experiment 1. If I substitute values for experiment 1, the rate is 0.256. K, I'm not sure. CLO minus 1 concentration is 0.2, but that's to the power X. And NO's concentration is 0.1, and that's raised to the power 2. That's experiment 1. And then you take experiment 2 and you substitute the values of experiment 2 in the rate equation. If you do that, the rate is 2.05, K is unknown, the concentration of CLO minus 1 is 0.4, power X, and the concentration of NH3 is 0.2, right? But that is squared. Achha, I know the rate equation, but I just don't know what X is. I mean, I know that rate is dependent on these two reactants. I know the order with respect to NO, but I don't know the order with respect to CLO minus 1. So I substituted the values for experiment 1 in the rate equation. X is the only unknown. I mean, there's K is also an unknown. And I substitute the values of experiment 2 in the same rate equation. and I'm going to divide the two equations. If I start to divide the two equations, so I'm going to get divide both sides, right? So the k is going to get cancelled out. Point. So this is 0.256 divided by 2.05. This side 0.2 square would come over here. 0.1 square would come over here, and you're going to get the middle part would be 0.2 divided by 0.4 power x. And I'm going to try and solve this. This would become half to the power x. And I'm not sure what this would be, but it's going to be, so let's find out. The left side. So what's 0.256 divided by 2.05? So then it's into 0.2 squared, and then divide by so this side is coming out to be half as well. So that means the value of x is actually 1. Is this clear? Aburaya, ye clear? Sara, is this clear? Akif, Mahfouz?
Yes, sir.
Yes, sir.
Yeah.
Acha, so लेकिन फिर से I'm just going to repeat. Akif, Sara, is this part clear that why you can't find the order with respect to CLO minus 1 like in the other methods? I mean, let me. Where's another table? Let's try and find. I mean, the first one, the first question that we did. Now, in this question, it was very clear that if you compare, let's say, if you compare experiment 1 with 3, then this is not changing. This is doubling. The first and the NO is doubling in experiments 1 and 3. So the rate was, I mean, you could find the relationship directly because O2 is not doing anything. If you want to find the order with respect to O2, you're going to compare experiments 2 and 3. O2 is halved and NO is not doing anything. So the relationship or the changes in rate are happening because of the changes that are happening in O2. The problem with this question is you can't do this type of comparison in this table. I mean, you can do it for NH3, like for example in 1 and 3. So in which one? In 2 and 3, NH3 was changing, but CLO minus 1 was constant. But you couldn't find any two experiments when you try to find the order with respect to CLO minus 1. Because you wanted to change CLO minus 1, but every time NH3 was also changing at the same time. ठीक है? ये clear है सारों को?
Yes, sir.
अच्छा, so we've managed to find. अच्छा, this method I would recommend that you can directly sort of read the table because it was only for 1 mark. So you should be able to read that knew the order with respect to NH3. It's doubling. So this should have been 4 times. But it's 8 times, so that means it's doubling again. So it's probably doubling because of this. That you doubled this and the rate is actually doubling. I say, anyways, you have to write the rate equation. We've already done that. We found the value of x. It's coming out to be 1. And they use the results to experiment 1 to calculate the rate constant. So what you're going to do is take the values of experiment 1, put it in the rate equation. You have the rate value, you have the CLO concentration, you have the NO concentration. So you can find the value of K in this experiment. That's the next one. Again, how does K change as temperature is increased? So if you keep on increasing temperature, K would also, it will also continue to increase. That's it. And it should probably start at the origin because if temperature is 0 kelvins, the rate should be exactly 0. No reaction should be happening. Is it the same question? Just 1 second. No, it's not the same question. It's a different question. I said, in another experiment, the reaction between chlorate and iodide ions in aqueous alkali was investigated. A solution of iodide ions in aqueous alkali was added to a large excess of chlorate 1 ions, and I minus 1 concentration was measured at regular intervals. Describe how the result of this experiment can be used to confirm that the reaction is first order with respect to I minus 1.
Using its half-life.
Exactly. You're going to use the half-life. So once again, Acha, so you measure the, and what half-life should you get?
Like half of the previous one.
In first order, the half-life is constant. You get a constant half-life. I mean, this is first order. Where's the, let's wait for this to open. So this one, where was the half-life thing? Probably after this one. So zero order is straight line. Nothing happens to the rate. So half-life constantly decreases. In order one, as the reactant concentration decreases, the rate slows down. So the half-life is constant. Every time it's constant. It's taking longer and longer for it to come to zero. And order two is when the half-life doubles. Like it's too dependent. If reactant concentration decreases, the rate slows down a lot. So it takes a longer and longer time for the reactant concentration to successively halve. So this one is, I mean, that's pretty much it. Um, Again, you have to deduce the overall equation for this reaction. So we can do the working over here. These are your reactants, and these are your products. Why waste time writing it again? So OH is on both sides. That's gone. Uh, who's on both sides? Cl minus 1. No, it's not. HClO is on both sides. Reactants. I mean, these are your reactants. These are your products. Acha, what else is HIO is on both sides? That's gone. So finally, you have, I think nothing else is probably going to, I mean, water is going to get cancelled out. That's on both sides. So your final reaction is ClO minus 1 plus I minus 1 on the left side, and the product side is Cl minus 1 and IO minus 1. That's it. So identify a step that involves a redox reaction. Explain your choice. That's kind of easy. Probably step 2. Step 2 is definitely, honey, step 2 is the one that's definitely redox, because I minus 1 is initially minus 1. And over here in HIO, that's being formed. H is plus 1, O is minus 2. So what would I be? I would be plus 1 as well. So it's changing oxidation. It is changing oxidation state. ठीक है, ये क्लियर है सारों को?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
अच्छा, अब अच्छा, okay, in each, I think we can draw the dot and cross diagram as well. He's saying in each ClNO2 molecule, the nitrogen atom is bonded to the chlorine atom and bonded to each of the oxygen atoms separately. And he's to separately, there's separate bonds. And did he tell whether it's a double bond or a triple bond? As each of the oxygen atoms separately. So we can make the dotted cross diagram. 1 second. So this is वो बीच में nitrogen. This is so बस मैं ये draw कर रहा हूँ. चलिए ठीक है, we'll continue with this, ठीक है, next class में continue करते हैं, ठीक है.
Okay, sir.
Where can I get this recording?
Video?
Yeah.
मैं send करता हूँ, ठीक है, मैं group में send करता हूँ, ठीक है.
Right. Thank you.
No.
Allah Hafiz.
Allah Hafiz.